LiDAR stands for light detection and ranging, which is a type of remote sensing that is used in order to examine different objects like the earth terrain and buildings. LiDAR uses laser beams to send out a pulse and then waits for a response to return back to the source to measure the distance from the ground to the detector. This data can be obtained over broad areas by drones, planes, and lasers on land. This is different than Lab 4 because in Lab 4 we had to take pictures and the physical structures were not shown on the actual map. They were only represented as dots where you could click on a pop-up to view the structures. With LiDAR, you are able to see this visual representation of 3D buildings on the maps themselves. Using the data that we were provided with, here was the angled photo that I was able to obtain. So this is at 45 degrees, and this is only looking at the buildings and the land from the model. And so this is what I looked at first, and then I was able to make a side view of the specific area that we were supposed to look at. So here is the building that was of interest, and here is the side view that I was able to create of that building. And the data in this Minneapolis area was taken in 8 points per square meter. This is because there was a lot of data in this area, so you had to take more points in order to get more accurate measurements. The vertical accuracy can be measured at a value down to the centimeter, and the data was collected in meters. The building of interest had a height of 51.08 meters, which is this distance right here, and had a width of 91.87 meters. This width of 91.87 meters includes a side walkout of the building, which I found out is the Guthrie Theater. So here's a picture of the Guthrie Theater, and this is the walkout that I'm talking about. And since this is still usable space, I decided to include it in my measurement of the width. So the next thing that we had to look at in this project was DEM, which is a digital elevation model that is represented in a tile map sheet. Each specific tile has a specific value which corresponds to its elevation. It does not contain any information about the buildings or the vegetation in that area. It only contains the bare surface, which is different than LiDAR. Since LiDAR is found with lasers, it gives you a fuller picture by providing X, Y, and Z values where you can identify the type of land or material that is being described at that point. In this sense, LiDAR is much more specific, where DEM is much more generic. So with using this data, I was able to create a 3D model. So here's the 2D model that I started with, and then by using the new 3D view, I was able to come up with this model. And so this model is very interactive. The elevation is set to display the output DEM. So if I use shift, I am able to shift the model around. And so you are able to place it more on like a straight on view, so you can actually see how the elevation corresponds to these buildings that we were looking at. And so if I bring it back to normal, then you can also zoom in on these buildings and really get a grasp of what the elevation is like around them, and the trees, and everything else that is going on in this model. So personally, I think that LiDAR could be very useful in researching the effects of new development projects on the environment. Due to the ability to identify specific plants and land types, you can check in on protected species more easily to make better predictions on the effects of human activity in these areas. This could revolutionize urban development by protecting all of our environment to sustain the earth we all know and love.